Hi folks, Mr. Long here. I'm just going to do a screencast about the chain rule, the different forms of the chain rule to get you ready for what's called U-substitution integration using the chain rule in reverse. So what we're going to do is we're going to do the chain rule as I said. Just quickly, here's our function that we're going to work with. And it's right here. I would really encourage you to make notes for this. So you're going to need to pause it as you go through this. So the chain rule. There's a function right there, 4 bracket sine x plus 3 to the 7th. And I think you're pretty familiar with that being our inside function, right? So the approach that we've used so far is what's called the Leibnez approach, named after the fellow that developed calculus along with Isaac Newton. Or maybe it's Leibnez. I would need one of my German students to pronounce it correctly for me. So, but we see, I think we can tell that's a composition of functions. There's a function inside a function. So in the Leibniz form, our inside function would be what we're going to call it u. And so u is sine x plus 3. And then we would do the derivative of that, du by dx. Like I could have f here. I can use any letters I want, but I'm going to start using u for the inside function if I haven't already with your class. So the inside function is u, and then du by dx is, the derivative of sine x is cos x, the derivative of 3 is 0. Then the outside function becomes, let's look back up here, so this whole great big thing is now u, so I still have 4 and 7. So that makes the outside y equals 4u to the 7th. And then I've got a y on this side and a u on this side, so that becomes dy by du. 7 times 4 is 28, the power rule, u to the 6th. Then I need to check and see if I've done it right, and if I have done it right, some things should cancel out here. So the du over the du will cancel out, and I'm left with dy by dx, which is good, that's what I want. And now I need to multiply the derivatives together. So I'm going to multiply cos x, and I'm going to multiply 28u to the 6th, but I have to recognize what u is. U is that inside function. So I'm multiplying 28 and cos x. Well, the 28 is going to come first because that's a coefficient. So 28 cos x, and then what comes after that is the inside function, u. Oh, and it was right here, sine x plus 3. So I come down to here, and I multiply that by sine x plus 3 to the exponent of 6. Okay, so there's our answer right there. Okay, so that's the chain rule. That's the approach that we've been using all along. Okay, so now let's look at a new way of doing it. We're going to do it with function notation. So like f of x and f of g of x. So it's the exact same thing, except now what we're going to do is we're going to rewrite this, and we're going to call the inside function g of x. The outside function will be f. Okay, so f at g of x. So this right here is your inside, and f is referring to your outside function. Okay, it's very, very same. So let's take a look at it. So over here, when I have the chain rule here, let me do this. Sorry about this. We always did du by dx. That was the inside. That's the outside derivative. Okay, so it's just inside derivative prime multiplied by outside prime. Well, if we do it in function notation, we're going to do the same thing again, right? So instead of writing it with u of x and y as a function of u, we're just going to leave it as f and g. So what have I got here? Well, if the inside function is called g, so start here, think through this. This is the inside function. Okay, so what's the inside? If g of x is the inside function, the inside derivative is g prime. If the outside function is f, then the outside derivative is f prime at g of x. Okay, so inside prime multiplied by outside prime. Really not changing, it's just the notation has changed a bit. So, so what I'm doing here now is I'm going to go through this specific example in front of you. So the same example we did before, but this time we're going to use function notation. By the way, we really need this function notation to be able to do integration and to do some other work that we're going to do in a little bit. Or maybe we've already done some, but okay, so sine x plus 3 again is the inside, 4 brackets to the 7th is the outside. So we're going to start calling this inside part here g. So g of x is sine x plus 3. And eventually you'll short form it to g of x and g prime. So there's the inside function, there's the derivative, g prime, that's cos x. What's the outside function? Well, it's f at g of x. All right, so where we used to write u, we're going to put g. So it's 4 times g of x to the 7th. Okay, and then what's the derivative of that? F prime of g of x is 4 times 7, 28, g of x to the 7th. So that's f prime at g of x. What's the derivative? The derivative is the inside prime multiplied by the outside prime. Okay, so next what we've got here is, well, what is y prime? So now let's write this down. So again, it's the same thing as last time, as the other strategy. So I'm multiplying g prime of x with f prime of g of x. So it's no different. 28, I'll use that first because I'll use the coefficient, is 28. So it's going to be 28, and then I've got cos x multiplied by g of x to the 7th. So what's g of x? Oh, wait a second. To the 6th, Mr. Long, I didn't reduce my exponent by 1. Sorry about that, folks. And then what was g of x? G of x was nothing more than sine x plus 3. Okay, so that's y prime, or dy by dx, whatever we want. That's the derivative. Okay, so 2 different ways of writing the notation. Let's do a couple practice questions here. So again, here is our derivative rule for the chain rule when we are using function notation. So when I have a function inside a function, so g of x is inside of f. That's called a composition. Then what's the derivative of that? Well, it's the derivative of the inside multiplied by the derivative of the outside in function notation. So how do I go about doing this? Here's an example. And again, I'd make sure you pause, rewind, go over things, get all the notes down. So for this one, the inside function is, that's going to be g, and then the outside function will be f. So g is, in this case, cos x. G prime would be negative sine x, and f of x is ln of g. Right, g is the inside. And what's the derivative of ln? 1 over the function. So the derivative is 1 over g. Okay, and to get our overall derivative, we have to do y prime, and y prime would equal, in this case, negative sine x times 1 over g. So my answer is going to be a fraction. So negative sine x times by 1 is negative sine x, and that's all going to be over g. And what is g? G is cos x. That's really interesting, isn't it? Y prime is negative tan x. We're going to come back to that later. That's a really tricky integral that we're going to get. So you're going to have to remember that when you go to integrate tan x, it's going to be a ln. Okay, so we're going to go, when we go in reverse. So again, I'm going to go back and look at that. I was doing the derivative of the ln of cos x. Okay, the ln of cos x. And when we do the derivative of ln cos x, the answer is negative tan x. That's a weird one. Okay, so here's the one I'd like you to try right now. So you're going to do this function right here, the derivative of that. I'll give you a hint. The derivative of 1 is 0. Oh, by the way, that if you don't remember, the derivative of tan is sec squared. I'll write that down for you. D by dx of tan x, in case you forget, is sec squared x. Okay, so what I'd like you to do now is press pause and just leave it right here and try and do this. So, I think I'll give you a hint. That might be just maybe your inside function. Okay, so list G prime, or determine G prime, list F, get F prime, and then multiply them together to get the derivative. Okay, so again, pause, go through that. Okay, hopefully you spent some time working through that. I'm going to give you the answer. It's right here. So you could see that, in fact, that was g of x. That's your inside function, and then your outside function is e to the g, or e to the tan x plus x squared. Okay. So you'll notice, again, the derivative is always g prime times f prime of g. So inside derivative times by the outside derivative. Or it could be outside derivative times inside derivative. Okay, so that is the chain rule in function notation. That's going to be very important as we move into integration by substitution.